Okay, baik. Assalamualaikum warahmatullahi wabarakatuh and a very good morning or afternoon to you guys. Okay, so today we're going to do the second subtopic, which is 2.2, charging and the discharging of capacitor. Okay, so before I begin, I just want to show back the energy of a capacitor. Okay, energy of a capacitor is U sama dengan half CV square kan. But you can also write this, since Q is equals to CV, we can eliminate the C, so you can actually write this as U sama dengan half QV. Okay, so eliminating the C, so C sama dengan Q over V lah. Okay, masuk ke dalam ini to get this equation, the second part of the energy. So you know this, energy dalam kita ada tiga. Okay, energy of a capacitor, half CV square, half QV. Another one is half Q square over C. Okay, so these are the three energies of a capacitor. Okay, I just nak you tahu, you can actually plot a graph of Q and V. Okay, Q and V, okay, you get a straight line. And seperti biasa, if you plot a graph of this and this, the area under the graph, area of this graph akan dapat you punya energy. So the area under here equals to the energy equals to U. Okay, so just nak you tahu lah, if dia bagi korang graph of Q against V, the area under the graph gets you back the energy of the capacitor. Okay, so that's that. So now let's go into our second subtopic, 2.2, charging and discharging of capacitor. Okay, so previously we've learned about capacitor lah. What is a capacitor? Instrument or an object that store charges. Okay, so dalam ni kita akan belajar tentang what happens when capacitor charge and discharge. Okay, so kalau korang dah habis on you punya first experiment, probably you dah tahulah macam ni capacitor charge and discharge, but I'm going to see this again lah here. Okay, so initially, let's see circuit kita. Okay, circuit kita macam tu. Okay, switch terbuka lah semua. Okay, so initially you punya plate is a combination of positive, negative, positive, negative, positive, negative, positive, negative, and negative, positive, negative, positive, etc. lah, is gabungan of charge. Okay, so bila you on you punya switch ni ke bawah, you on you punya switch, what happens? You can read this while saya explain lah. When you on the switch here, current will flow. Okay, so the current is defined as the flow daripada positive terminal ke negative terminal, but yang penting di sini adalah the electron flow. The electron will flow from the negative terminal up until the positive terminal. So negative electron akan bergerak to the negative akan gerak sini lah. Okay, so sini akan accumulate negative. Okay, so bila sini accumulate negative sini akan bertemu dengan negative sini. So when negative bertemu negative, it will push out this negative electron keluar, leaving this plate to become more positive. Okay, more positive. So the negative sini pun akan keluar, will travel to the battery, pergi kepada the negative plate. So sini akan jadi makin lama makin negative, up until semua jadi fully negative, fully positive. Okay, so electron will flow from the negative terminal, accumulate to part B of the capacitor. So the electron will flow out. Sebab apa? Sebab sini negative, the negative will push out the negative at plate A. Okay, so sekarang ni plate E akan jadi more positive compared to plate B lah. Okay, so what would happen when you have a positive and negative here? Akan ada electric field. Tapi what happens yang penting sini is the potential. Okay, the potential V here akan sentiasa meningkat. Sebab this will become more positive, this will become more negative. So the potential between the plate akan meningkat lah. Okay, dulu dia tak banyak sangat, dia ada positif, negatif. Sekarang ni dia ada satu side positif, satu side negatif. You see this as almost like a parallel plate capacitor balik kan. A parallel plate lah waktu 1.4 we've learned. Okay, so the potential meningkat. Okay, charge pula akan makin bergerak. Okay, charge of the electron pula bergerak pergi negative plate, pergi negative plate. Okay, so that's the fourth part lah. Okay, the potential difference increases. Okay, dan selepas kalau potential difference meningkat, we know that V equal to IR kan. So from here, kalau potential kita meningkat, supposedly our current okay, not a very good explanation sebab korang tak belajar lagi. This is in the third chapter lah, tak yalah. Okay, saya just nak korang tahu the potential V here akan meningkat, tapi the current I akan menurun. Kenapa dia akan menurun? Sebab we define current as the flow of charge. Okay, so makin lama, okay, bila plate ni dah jadi fully negative, ini fully positive, okay, the electron takkan masuk dah. Okay, sebab sini jadi fully negative, electron dah tak masuk, you punya current dah tak, what call the electric charge here takkan bergerak. Bila takkan bergerak, you punya current akan stabilize, okay, akan berkurangan lah. So daripada current tu meningkat, initially dia meningkat, dia bagi charge ni bergerak, dia bagi tenaga untuk charge ni gerak, it will become up until a point bila current kita akan menurun lah, akan menurun and will stabilize at one point. So that's why kita punya graph of current looks like this. Okay, looks like this. Okay, so hopefully explanation tu dapat. Okay, so you can read it again. Switch tutup. Bila switch tutup, what would happen? Electrons would flow to the negative plate. Negative plate akan tolak the negative plate of the plate A. Okay, negative plate of plate B akan tolak the negative plate of plate A. Negative plate A ni akan pergi balik pada plate B, leaving the plate A with fully positive and plate B with fully negative. Okay, potential difference meningkat, current menurun. Okay, and when there's no more current flow, okay, kita katakan benda ni sebagai fully charged. Fully charged. Okay, bila dah tak ada electrons semua flow, we call this as fully charged. So this is the graph of Q of the charge, of the voltage, and this one is of the current. Okay, so hopefully korang boleh nampak lah kenapa dia punya charge meningkat sini. Okay, so dia meningkat sebab firstly tak ada apa-apa, but when you on the switch here, charge would flow kan. Bila charge flow, pergi kepada positive, pergi kepada negative plate pula akan bergerak dia punya negative charge pergi balik pada plate B, so the charge akan meningkat exponentially here lah, exponentially, and you can write the equation as this one lah. Okay, so equation as Q sama dengan Q naught 1 minus E negative T over RC for charging. Okay, for charging. Okay, it's a bit different from discharging nanti. Okay, what about for the voltage? Macam saya kata, this one will be more positive, this one will be more negative, so dia punya voltage pun akan meningkat sama. Okay, and equation dia pun is similar, you just change the Q into V lah. However, the current would decrease as the voltage here increase, the current here will decrease. Sebab sekarang ni bila semua ni dah fully positive, fully negative, you punya charge dah tak ada reason nak pergi pada negative plate dah, sebab dah jadi fully negative, so it will become standstill, so you punya current semakin berkurang. So it's more like initially at this point, okay, plate U ada combination of positive and negative, tapi makin plate kita ada positive, makin plate kita lagi satu tu negative, so it will come up until a point where current tu dah tak perlu dah untuk menggerakkan dia punya negative electron. Okay, sebab dah full, so the potential V here will be equal to V naught. Okay, so bila dah equal, current has no more use untuk menggerakkan ni punya electron. Okay, so that's why the current diminishes, and you punya equation is I sama dengan I naught E negative T over R C. Okay, so you can read here kenapa charge bergerak, kenapa potential kenapa charge bergerak lah, kenapa charge berupa macam ni, kenapa potential macam ni. Okay, charge increases as electron flow up until a maximum charge Q. Okay, due to the increase of the positive and negative charge between the plates, macam saya kata tadi, the voltage increase up until a maximum. Okay, please know lah this equation, sebab lepas ni we'll learn about discharge pula. Okay, so this is how a capacitor charges up. Okay, now what would happen if contohnya sekarang ni saya buka bateri ni. So bila saya buka bateri ni now, tak ada apa nak paksa my electron to flow dah waktu initially dah. Okay, so when I remove the battery now, see, no battery, what would happen is now, sebab sekarang ni sini ada negative, sini ada positive, the negative of this charge akan sendiri bergerak to neutralize the positive bit. So when the switch S is closed now, no battery here, the electron from part B will flow through the wire and the resistor to neutralize the charge on the positive plate. Okay, so sekarang ni negative akan pergi kepada the wire to neutralize the positive plate. So apa? The negative again attracted to the positive. So dia nak pergi ke sana dia melalui the wire. So dia pergi and neutralize. So initially ada potential difference V yang besar kan. So makin lama dia makin berkurang. Sebab apa? Sebab the negative will try to neutralize the positive. Okay. So starting from the maximum voltage Okay, kalau tengok graf ni lah, graf kita. Okay, starting from our maximum voltage tadi, dia akan berkurang sebab sekarang ni our negative charge will neutralize the positive charge lah. And what about the charge here? Okay, so the charge initially akan bergerak kan, but there will become one point bila semua the positive charge ni akan neutralize and semua ni jadi neutral. The negative pun akan biar at the stable point. Okay, akan ada a point where it's stabilized lah. So you punya charge pula bila dah stabilize takkan bergerak. So that's why the start with the maximum charge and akan berkurangan. Okay. So when the part of the positive charge E is neutralized by the electron, the voltage across the capacitor is reduced. The process is continued until the current in the resistor is 0. So the current pun is still the same, akan berkurangan. Macam sama je macam kita punya charging and charging tadi, cuma in this case the current is defined as a negative here. Okay. Ni formula ni pun is defined like this, so saya pun tak boleh buat apa. So that's why you punya initially it looks the same as kita punya charging punya graph, tapi because there's a negative part, okay, you'll get a negative mirrored lah, negative mirrored from you punya initial charging point. Okay, so at this point all the charge in plate A akan fully neutralize and the voltage becomes 0. Okay, so again yang bezanya di sini is contohnya dalam kita punya charging tadi kita ada 1 minus Q. Okay, 1 minus Q. So if you see here back, nampak tak ada 1 minus Q pula, sorry. Okay, not 1 minus Q. Okay, not 1 minus Q. Okay, dia ada what you call back kita punya ni lah. Q sama dengan Q naught 1 minus E negative T over RC. Okay, so the thing yang banyak kita nampak sini is what you call the T lah. Okay, the T. So again for charging ada 1 minus semua. For discharging, okay, tak ada apa-apa 1 minus. So that's one of the tip to remember lah. Okay. So now yang penting tadi the value of T. What is T? Okay, hopefully semua tahu R dengan C. R and C is the resistor. Okay, and C is the capacitor. Okay, hopefully you know this lah daripada you punya eksperimen pertama. Okay, so now we're going to look at this value T. What is T? T is time. Okay, T is confirmed time lah, but time of what? Okay, so T ni is defined as the time constant tau. Okay, tau. Okay, so tau ni is basically a time untuk charging and discharging. Okay, so definition is a measure of how quickly the capacitor charge or discharge. So basically time here shows the time of charging and discharging. It's scalar quantity and the SI unit is dalam second. Okay, so apa maksud time tau ni? Okay, time T sama dengan tau. So dia measure for kita punya charging, okay, charging and kita punya discharging. Okay, kalau charging, it is time required to get to 63% of the maximum charge, which is Q naught here lah. Okay, for discharging pula, it is defined as time taken for it to reduce 37% of its initial charge. Okay, but dari mana datangnya kita punya 63% and 37% ni? Okay, so the 63% and the 37% actually comes from bila you punya T sama dengan R, kita punya T equals to tau, which is equal to RC. Okay, so bila T equal to tau equal to RC, let's see kita punya ni bila discharging here. Okay, so the discharging punya akan dapat Q equal to Q naught E negative T over RC kan. So bila T equal to tau equal to RC, you akan dapat equal to Q naught E negative 1. Okay, sebab you substitutekan RC you inside, you akan dapat negative 1. Okay, so Q equal to Q naught E to the power of negative 1. Bila negative 1 ni, you akan dapat actually 0.37. Okay, Q naught. Okay, so this is the time yang kita define for discharging. So for charging pula, it's basically 1 tolak the 0.37, which equates to 0.67. Okay, so that's why kita punya charging tadi ada 1 minus. Okay, so as you can see here, the 1 minus kita punya ni refers to 1 tolak ni, sebab this one would yield 0.37. So for the charging part, you'll get the 63% lah. Okay, daripada situ datangnya lah 63% and 37%. Okay, so that's how it is defined lah. Okay, it is defined. Okay lah kot. Okay, so again, the main thing here is you need to know how to differentiate the different equation of charge, of current, and also of voltage lah. Okay, and you need to know about the time constant T. Okay, time of measurement. And T ni bila you nak charge and discharging ni, it is equal to tau, which is equal to RC. Okay, so let's try a few example. Okay, for question 7 and question 10, you can pause the video first. Okay. Okay, dah pause ke? Okay, hopefully you dah pause, you dah try to do question 7 and question 10. Okay. If not, let's try to do it together lah. Okay, so for question 7, okay, question 7 dia beritahu sini a capacitor of 3.03 microfarad is charged using a 2 volt battery. Okay, the charged capacitor is then discharged to a 60 kilo ohms resistor. So what is the time constant of the discharge current? Okay, so again, time constant T equals to tau equals to RC lah. Okay, so if you want to find the time constant, which is tau here, okay, which is equal to RC. Again, RC apa? It's just resistor and capacitor. It's here, it's a quantity RC that appears in the exponential of all the equation in charging and discharging process. So again, T is equal to tau here lah. Okay, so macam ni you nak cari RC, dia bagi tak? Dia bagi you resistor of 60 kilo ohms and capacitor of the 3 microfarad. So 60 times 10 to the power of 3, okay, darab dengan resistor of 3 times 10 to the power of negative 6. Okay, so if you multiply this together, you should get you punya tau equal to 0.18 second. Okay, tu you punya tau lah, time constant, settle. Okay, simple. Remember, kalau time constant apa, it's tau, it's equal to RC. Next for question B, okay, find the time taken for the charge on the capacitor to decrease 50% of its initial value. First thing you need to note is bila dia kata decrease ni, it is discharging. Okay, discharge. So you punya Q equal to apa? Jangan 1 minus. 1 minus tu is the charging, so it's Q equal to Q naught E negative T over RC. Okay, so for this type of question, you kena tahu bila dia decrease 50% is actually apa? Q is equal to 50% or 50% Q naught or 0.50 Q naught. Okay, so you boleh substitutekan QU equal to 0.50 Q naught. So 0.50, okay, 0, alamak. So 0.50 Q naught equal to Q naught E negative T over RC. So you can cancel out the Q naught, okay. And bila you cancel off the Q naught, you akan dapat 0.50 equal to E negative T over RC. So then what you do, you ln both side, okay. Kenapa kita ln lah sini, bukan ln both side? Sebab kita nak hilangkan dia punya exponential. So ln 0.50 equal to ln E negative T over RC. So the ln cancels out, okay. So the ln of you akan dapat sekejap. Ni saya bawa belah sini lah, okay. Ln 0.50 sama dengan negative T over RC. Again, you punya RC is calculated above, okay, which is 0.18, okay. So ln 0.50 equal to negative T over 0.18. So basically you akan dapat T sama, rasanya dalam ni ln bawah 1 you akan dapat negative tau, okay, negative. So you akan dapat time of 0.12 second. So what does it mean T sama dengan 0.12 second? So it is the time taken for the charge to decrease 50% of its initial value. So kalau charge kita, okay, okay, so sini tadi charge kita. So kalau contoh charge kita adalah 100, so dia mengambil masa 0.12 second for the charge to decrease to 50. Okay, so this is the time taken for the charge to decrease to 50% of the initial value, right? So that's for question 7 as an introduction pada our subtopic 2.2. So now let's try for question number 10. Okay, a bit interesting lah. A bit interesting for question number 10. Again, I'll give you a bit of time to try to do. Okay, mungkin boleh pause the video before I explain lah. Explain macam nak buat. So, you boleh pause dulu. Okay, dah pause ke? Hopefully korang dah pause and try to do it for yourself. Okay, so for question 10, okay, dia bagi sini lah. Okay, circuit kita yang ada dua switch, ada battery of 10 volts, ada capacitor of 2 microfarad and ada resistor of 2 mega ohms. Okay, so Describe in word the meaning of capacitance. So this is inside you punya lecture note, or if you want to write it down, capacitance apa definition dia tadi? It's defined as the amount of charge stored, okay, on each plate per unit voltage, okay, or you can check lah the ratio of charge stored per unit voltage pun diterima. Basically dia datang Q equal to CV, so the capacitance C equal to Q over V, right? So that's for question first. Okay, so for question B, calculate the charge of the completely charged capacitor when switch S1 is closed and switch S2 is open. So when S1 is closed, what would happen? Again, charge would flow. Okay, charge would flow. Sini akan ada negatif, sini akan positif. Tapi sini takkan flow. Kenapa? Bila you punya electron flowing here, the electron takkan masuk pada junction ni. So ini terbuka. So circuit bawah ni is completely useless lah in this case. Okay, so kalau dia minta soalan minta charge, so just use Q equal to CV. Kita ada ke semua? Okay, you have you punya capacitance of 2 microfarad, you have you punya volts of 10 volts. So instantly you can do here 2 times 10 to the power negative 6, okay, and our volts of 10 volts, which would net you 2 darab 10 kuasa negatif 5 capacitance pula, coulomb C. Okay, so that's you punya charge Q lah, you punya charge Q. Okay, so that's for question B. So question C pula, switch S1 is then open. So dia buka balik switch S1 ni. Okay, dia buka balik switch S1, okay, and then switch S2 pula tertutup. So what will happen now? The capacitor akan discharge. Okay, so sekarang ni the capacitor here akan discharge lah. Okay, so bila discharging process happens, okay, again the negative would flow here to neutralize the positive bit. Okay, so the initial charge QU adalah berapa yang kita cari tadilah? 2 darab 10 kuasa negatif 5. Okay, so calculate the percentage of charge. Okay, so this is something new lah, percentage of charge. Okay, left in the capacitor after T sama dengan 8 seconds. So you punya T ataupun tau here is 8 seconds. So again, this is the process of discharging. So the discharging punya equation Q equal to Q0 E negative T over RC. So kenapa saya guna Q bukan guna I, guna V? Sebab sekarang ni kita nak calculate percentage of charge. Okay, jangan mandai korang guna I atau V sini sebab soalan minta charge. Okay, so kita punya Q here is again the same thing as yang Q ni lah kita nak cari. Sorry, ni mana ke? Q kita bukan ni Q0, okay, initial, okay, Q0, sorry, it's Q0 equal to 2 darab 10 kuasa negatif 5, bukan Q, Q ni yang kita nak cari. Okay, so Q equal to 2 darab 10 kuasa negatif 5, our initial charge. Okay, E negative, what is our T? 8 seconds over the resistor here is 2 darab 10 kuasa 6 mega. Capacitor kita adalah 2 darab 10 kuasa negatif 6. Okay, kita punya capacitor here lah. So kita akan dapat charge Q will be equal to here. Okay, kita akan dapat sepatutnya if you calculate here, you can dapat 2.71 times 10 to the power of negative 6 coulomb. Okay, so what happens here? This is our charge selepas 8 second. Okay, our initial charge is this is our initial. Okay, this is our initial, this is our final charge. So how do you find the percentage? Okay, you find the percentage adalah daripada apa yang you cari, kita punya Q divided by kita punya initial times 100%. Okay, so from here it is actually 2.71 times 10 to the power of negative 6. Okay, divided by initial charge kita adalah 2 times 10 to the power of negative 5. Okay, times 100%. So hopefully you can dapat here 13.5%. Okay, so it's always the new thing divided by the initial thing times the 100%. You'll get 13.5% as you punya what I call the charge left. Okay, yang tinggal lah selepas 8 second. So benda ni always occur instantaneously. Okay, so bukanlah macam kita punya power bank. Power bank ambil masa yang lama kan untuk charge kita decrease. Okay, so that's for question number 7 and 10. Okay, so try to do the LO 2.2 here lah. Okay, so I'll see you guys again in the next hour. Untuk kita habiskan chapter 2, kita akan pergi on capacitor and dielectric. Okay, bye.